I have a building. I have a building looks like this. Just to give you, because this one looks like the small project we will work in the week before just a week after the Thanksgiving. This plan for an apartment, for a building. Here is the stairs. You are entering the apartment from this door, main door. We have living room here. Then we have distribution bath. We have a bedroom. We have bedroom. We have another bedroom. We have a bathroom. We have a kitchen. We have another 2 bedrooms by the end of the apartment. So we have how many bedrooms? 1, 2, 3, 4. Wow, it's fantastic. So this is this plan called architectural plan. Architectural means design, but it's a different design. What do you mean by different design? This architectural design is showing where is the bedrooms, the living rooms, the stairs, the bathroom, the kitchen, the walls, bathrooms of the building or the apartment. So this is called architectural design. You are in this course is structural design, structural designer. You are in this course, or your major give you the opportunity to be structural designer. What is the difference between a structural designer and architectural designer? As I told you, the architectural designer only concerning about the layout of the building. The layout. Where is the stairs? Why your stairs is here? Why not in this area? This is the layout of the building. Okay? So we have 4 bedrooms. Why they are not 3? Who is deciding this? The architectural designer. Okay? So the architectural designer give me this layout. What is my rule? My rule is I have many questions and I need to answer as a structural designer. Where is the columns? Where is the footing? What is the type of slab? Is it one way? Is it two way? Is it two way with beams or without beams? Is this building is safe against earthquake? Is this building safe against wind load? So I need to answer the question related to structural design because I'm a structural designer. Okay? That makes sense? Guys, that makes sense for you? Okay. So, do you think, so the first step in any building in this world, any construction in this world, the first step is the architectural design. The architectural design. So any project in this world started by this architectural design. And this design only showing you where is the walls. Just walls. And the layout of this building. That's it. That's it. Nothing else. Then we need structural design. The first step in structural design is the layout of columns. Column is the first step before slabs, before beams, before foundation, because column will decide all of this stuff. If you put columns first, I will decide I will put beams or not. I will use one-way slab or two-way slab. Columns will decide where are the footing. So the first step is columns. Where can I put my columns? I have question. Guys, do you think I can put a column at this area? What is the problem? No, I have a big problem. So imagine you are entering your apartment in the living room and you find a column at the mid area. That makes sense? Doesn't make any sense. So I cannot put columns without architectural drawing, without architectural design. So I have to get this architectural design to help me to find, to locate the layout of columns. That makes sense? Yes, yes, because this room 211 was not designed to be a classroom. It was designed for something different. They bought the columns for the other function. Then they changed their mind. So we have issue with the architectural design. Okay. So I think I'm gonna put a column at this corner. This corner. That makes sense. This corner. This corner. This corner. Columns must be located at the corner of the layout. Probably I can put a column here. That's fine. Probably I can put a column here. Probably I can put a column here. Here. There. At this location, it will be good. I didn't say all corners. I didn't say this, but the best location for columns is the corner. Probably here or here, whatever. So if you watch this layout of columns, I think I'm good. I think I am good. I have another question. Anybody can tell me the distance between this column and this column will determine what? Because you have to keep this in your mind. The distance between this column and this column will determine what in the future? The length for what, Cody? Thank you, Alex. Yes. Yes. Even if you are not using beam, it will decide the span of the slab. Do you remember, guys? If you have a slab without beams, we have something called column strip. Do you remember that? Column strip. If you decided I'm not using a column, I'm not using beams. Okay, but remember we have a strip here. This strip called the column strip will be represented like this, and the bending moment will be like this. And this moment, if you remember, WL squared divide 11. What is the meaning of L? WL square divide 14 or divide 16. What is the value of L? The distance between this column and this column. So, because one of you will say, hey, what is the problem if I put only two columns? One at this corner and another one at this corner, and that's all. Okay? But the distance between this column and this column will be 10 meter or 10 feet or whatever the unit. It's too long. So please, when you are designing a building and you are trying to locate the layout of columns, you have to keep in your mind two things. The first one, please don't disturb this architectural design. Don't destroy this layout by putting a column here or here, so you cannot put your bed, or here in the bathroom. So when you are entering the bathroom, you will find another column at the mid of the, doesn't make any sense. Okay? So this is the first one. The second one, also keep in your mind the distance between a column and the adjacent column or the consequent column will decide the span of the beam or the slab rested on these columns. That makes sense? Looks good. Looks good. Once you decided where are your columns, I am done. I have a column. I have a footing. Easy. More easy. I have a column. I have a footing. I have a column. I have a footing. Probably you have a neighbor. So I'm not sure if you put your footing at the edge of the column like this, or if you don't have a neighbor, everything is good, I will put the footing like this. Sometimes, for any reason, we need these two columns, this one and this one. So the design of the footing of this column looks like this. And the design of the footing for this column looks like this. Wow, we have interaction between the two footing. What is the solution for this issue? We will use something called combined footing. Do you like this story? Do you like this story? It's a good story before sleeping. Okay. So this is a long story, but it's very interesting. I believe what I said here is more important than how to design a footing, because you need to understand what's going on. What is the big story behind any building? I promise you, but the last week in this semester, we will learn this layout from scratch, from A to Z. Okay, I will use a software and help you to finish up the design of column using Excel, the designing of beams and the slabs using a floor, RISA floor, and the design of footing using RISA foundation. Promise. But please promise me you will be interested, because this bar or this week will be very, very, very important. Okay. So guys, for some reason, we have two columns very close. So I decided to design isolated footing for this one and another isolated footing for this one. I found overlapping. I found interaction. I found they are very close. Probably there is no overlapping, but they are very, very close, like this, very close to each other. The best solution for this issue is combined footing. So combined footing supporting more than one column, two columns. One situation in which they may be used in when the columns are so close together that isolated individual footing would run into each other, overlapping. Another frequent use of combined footing occurs where one column is very close to a property line, probably. So we expect a column at the edge of the footing. So we prefer to use combined footing with another column to make sure no overturning. Okay. So actually, I will not decide to use combined footing at the beginning. No, I have to try first isolated footing. Failure to use isolated footing will push you to use combined footing. This is very important because some of you will ask me, hey, when I will decide to use combined footing? Actually, I have no answer for this question because I have to decide, I have to try first isolated footing. Failure to use isolated footing, you have to use another type of footing, which is combined. Why you failed to use isolated footing? For two reasons. They are very close or there is overlapping between the two footing. Any question? Any question? Okay. It's very easy. First step, we need to figure out the area of footing. Equal P divide Q net. As you know, P that used with Q net to figure out the area required of the footing is dead load plus life load without factors. And that makes sense. Q net is Q allowable minus gamma concrete H footing minus gamma soil H soil. I can figure out the area required. Guys, we need to make sure we have uniform pressure or uniform stress under the footing. So the footing dimensions are selected so that the resultant force coincides with the centroid of the footing. Guys, we have two columns, column number 1 and the column number 2. Column number 1 is supporting, for example, 100 kib. Column number 2 supporting 150 kib. That makes sense. The two forces on the two columns are different. That makes sense. This force and this force of the two columns has a resultant force R. Please make sure that this R at the centroid of this footing. What you mean by centroid of this footing? I mean this distance from this side must be the same distance from the other side. That makes sense? That makes sense? This footing is supporting two columns. This column has a force P1. The other column has a force P2. The two forces are different. That makes sense. Each column supporting different loads. Can you see here? Each column is supporting different load. This column supporting this area only. This column is supporting this area. So there is a big difference. So what should I do? I need to figure out where is the resultant force R. This R between this column and this column, I'm not sure where, must be coincide with the centroid of this footing. Okay? Once you figured out this total distance, I can figure out the width of the footing, because length time width equal area required, that you get it from this equation. Let's do this example and see what's going on. We have two columns. The first one, 18 times 18 inch, dead load equal 120, live load equal 100 kip. Second column, 20 times 20, B dead load equal 200 kip, B live load equal 150. The distance between this column and this column, center line to center line, is 12 feet. And we have a property line. That means I cannot extend my footing to the neighbor area. So select the dimensions of the shown rectangular combined footing for the two columns, given Q allowable equal 5,000. So guys, if you don't have any information about no, we have some information here. The bottom of the footing is to be 6 feet below grade. Ground surface. Here is the footing. This depth of excavation, 6 feet. So I will assume this thickness probably 2 feet, 24 inch. So assume each footing equal 2 feet, 24 inch. So each soil will be 4 feet. So Q net equal Q allowable minus gamma concrete H footing minus gamma soil H soil. Q allowable is 5,000. Gamma concrete 150, H footing 2 feet. Gamma soil is given 115. H soil is 4 feet. So I can figure out the Q net. 5,000 minus 150 times 2 minus 115 times 4, 4,240 pound per square feet. P For this column, P1 equal 220 kip. P for this column equal 350 kip. So the total P for this footing will be 220 plus 350 equal 570 kip. So the area required, which equal P divide Q net, P 570 kip will be multiplied by 1000 to be in pound, divide Q net, which is 4240. $134.4 feet. I'm sorry, feet square. It's area. Any question? Any question until this moment? We didn't do anything new. I figured out the QNet. I figured out the total load. Then I divided the total load by QNet to figure out the area required. We need to convert this area required to dimensions. So please pay attention. I have a column here with P equal 350. I have another column here with a P equal 220, I think. Yes. The distance between the two columns, center to center, is 12 feet. Where is the resultant force? By the way, resultant force equal 570 kip. But where? Where? R. Okay. I will assume this R at a distance X from this column. Take moment at column 1. First column, second column. If you take moment at column 1, 220 will be multiplied by 0. We don't have distance for this load because I'm taking a moment at the first column plus second column 350 load time distance 12. This moment must be equivalent to R time distance X. So here is the applied loads. The other side, here is the resultant force. And I decided to take moment from this column. So the distance for the resultant force will be measured from this column by distance X. Put the value of X, put the value of R, 570. The only unknown in this equation will be distance X. The distance X will be 7.4 feet. 7.4 feet. Any question? We need to figure out the resultant force because I don't have one column. I have two columns. So where is the resultant force for the two columns? I found it to be 7.4 feet from the center line of the first column. Okay. So this distance, here is the resultant force R, and this distance to this column, to the centroid of this column, 7.4 feet. Can you tell me what is the distance between this centroid, this resultant, and the edge of the property line? Can you? Thank you, Oliver. 7.4, but 7.4 is feet. 9 divide 12, that's fine. You are right, Oliver. But Burak, how did you get 8.9? I will not add 18. Burak, I will not add 18. I will add half distance for this column, which is half 18, which is 9. Okay? So this distance will be 8.15 feet. Go ahead and add another distance to the other side, 18.15. So the total length of this footing will be 16.3 feet. And I am good because the resultant are at the midpoint of this footing, 8.15 from this side and 8.15 from the other side. So the length of this footing equal 16.3 feet. One more time. Once you figured out where is the centroid, please, the distance between, where is the resultant force? The distance between this resultant force and the edge from this side, property line, must be the same value or the same distance from the other side. So 88.15 from this side, we should have 8.15 from the other side. So the total length is 16.3. Guys, the area required for this footing was, what is the value of the area? 134.4. So the width of this footing will be this area divide this length will be 16.5. So the final conclusion, this length will be 16.5 and this total length is 16.3. I am good. I designed the footing, or I designed the dimension of the footing. That's enough for this course. We don't need to figure out the bunch or the shear or the bending moment. It's more complicated a little bit, and it's very, very, very long. We will use a software to finish up this footing. So I need only to understand, to learn how to figure out the dimension of a combined footing. First step, after you figured out the unit value, first step, where is the centroid? Where is the resultant force R between the two columns? Once you figured out the resultant force, make sure this resultant force at the centroid of this footing. That's it. That's all. Okay. Really? Are you sure? Yeah, looks good. 134.4 divide 16.3. I'm not sure how did I get 16.5, but anyway, thank you. Looks like my calculator is missed. 8.2 or 3 feet. I'm sorry. You are right. So this one will be 8.3, and that makes sense. 8.3. So 134 divide 16. Yeah, that makes sense. Thank you. Check of bunch, check of shear, reinforcement, everything is the same like isolated footing, but it's very, very long because we have two columns. We need to convert this footing to a beam and draw shear force diagram, bending moment diagram. And from these diagrams, I can design the footing. Looks like a beam, but it's not a big deal. Nothing new, so I will stop until this point. Yes. Yeah. At this moment, Alex, yes. You have two options at this moment. Look to me. Okay, I have a column and I have another column. We don't have property line. I found the resultant R here. What should I do? You have two options. The first option, this R is far away from this column. So I will measure this distance and I will put the same distance on the other side and I will say here is the length of the footing. You got it? So I didn't assume anything. I just say, hey, the distance between this resultant force and the farthest away column is this one. Please put the same distance on the other side to figure out the edge of the footing here. Or we have a column, we have another column, and I have R here. It's up to you. If you decided this edge of the footing here, please measure this distance and put the same distance on the other side to figure out the edge of the footing here. Once you figured out the length of the footing, I can figure out the width. This one is up to you. Okay, so you have this option or this option. Even if you don't have property line, I decided to make the edge of the footing and the edge of the column. I decided this. That's fine. Thank you, Alex, for your question. It's a good question. You have the third problem in the homework related to this one, something like this. You have a footing, combined footing, and we need only to figure out the dimension of this footing. Any question?